Okay, so here we are working on the problem that we started in class. Sorry that we didn't have time to finish it. But this was looking at different blood types and whether or not the individual had the sickle cell trait. So this is the problem that we're started with. So let's see if we can finish the chi-squared for it. So, okay, so the first thing that you want to do is start with the phenotypes. And the phenotypes that we have in this case are type A, type O, type A, type O, type A, or type O. The individual can have normal. They can have normal for O. They can have the sickle cell trait for A or for O. Or they could have the sickle cell disease, the actual disease itself, with a homozygous form of those alleles. So the observed were given to us in the packet. So these are the numbers that we went through. They told us what these numbers were. And to find the expected, so this is what I wanted to go through again, you would have to set up a Punnett square looking at these different combinations. Okay, so based on these combinations, you would have to create a Punnett square, a dihybrid Punnett square, that's going to show us exactly what we would expect from this. So if you fill that out, you would find that 3 out of the 16 possibilities would have a blood type and would be normal. So we multiply 3/16 by my total, which is 224, so I get a result of 42. Okay, we follow this pattern for the remaining different traits, and the numbers that we get for that are 14, 84, 28, 42, and 14. Okay, so we can already start to see that some of them are similar and some of them are a little more different. So for example, our bottom trait that has type O blood and the sickle cell disease is pretty significantly different between what we expected to see and what we actually observed. The next step is simply subtracting, okay? So taking our observed value and subtracting it from our expected. So in this case, we would have 48 minus 42, and we would get 6. Okay, so you do this for all of them. So 18 minus 4 is 4, 92 minus 84 is 8, 33 minus 28 is 5, 27 minus 42 is negative 15. We remember that that's okay because we are about to square them. The negative number will go away. And the last one is 8. Okay, so awesome. Now we've started this. The last part to do is just to square that number. So essentially 6 squared. And dividing that by the expected, which in this case is 42. Okay, so if you do that, you should get 0.86. If you follow that trend for the remaining ones, you get 1.14, you get 0.76, you get 0.89, you get 5.36, and you get 4.57. Okay? So once we have the chart filled in, we've done the tough part. Let's start by answering some of these questions to determine what our chi-squared actually is. So the next thing that we want to do is determine what our chi-squared value actually is. And to get this number that we're talking about right here, we want to actually use this column and add it up. And to do that, we're literally just going to add up those different numbers, and we should get an answer of 13.58. Okay, so that is our actual chi-squared value. Now in class, we talked about the fact that the DF, or the degrees of freedom, are the amount of different possibilities I could get. So if we look up here, I have 1, 2, 3, 4, 5, 6 different possibilities, possible phenotypes that I could get. So the DF is n minus 1. So in this case, it would be 6 minus 1, or 5. So our degrees of freedom is 5. So on our chi-squared chart, we are going to use only the row that has 5 labeled. So in the very first column, we're going to go all the way down to the bottom, and we're going to look at that row. okay? Using the critical value table to determine the p-value. So let's actually look at that value right now. So if we look forward to, so if we're looking at our actual chi-squared values table, remember we just mentioned that we want to be in the 5th row, okay, because this is what we have determined our degrees of freedom is. So everything else on this table does not matter at this point. We are only concerned with this particular row. And if we look back, we remember that our chi-squared number is actually 13.58. Okay, so in this row, I want to find where 13.58 would land, and I know that it would land right in here. Okay, so this is telling me that my chi-squared value gives me a p-value of between 2.5 and 1%, okay, which is a really small value, and that value is telling me that there is a 2.5 to 1% chance that the difference in the expected versus the observed values that I got is due to chance. So that's a really, really small number, meaning that it's probably not due to chance. A 1% chance is not very great. So if we think about the last two questions that they ask us when they're saying to interpret what that p-value means, we can say that the null hypothesis is rejected, okay? Meaning that this is not due to chance. There is something else that is influencing it. And I encourage you guys to try to answer part E when it thinks about why would it be beneficial for this particular population to have the sickle cell trait. That is what E is addressing. Email me with questions.